Let's look at solving radical equations, or equations with roots in them. The first step is to isolate the square root. In other words, get the square root on one side of the equation by itself. From there, we can square both sides of the equation. We can then solve that equation using other methods. And it's very important to check our solutions with radical equations. It is possible that we get something that actually doesn't work. So let's look at some examples. My very first one, the square root of x plus 8 equal to 3. We already have the square root alone by itself on one side, so let's square both sides. Squaring a square root just gets rid of the square root, so the left-hand side becomes x plus 8. The right-hand side, 3 squared is 9. We can then subtract 8 from both sides to get x equal to 1. And it's very important to check these. I would have the square root of 1 plus 8 equal to 3. That says the square root of 9 is equal to 3, or 3 is equal to 3. So this is a valid solution. So this would be my solution to this equation. For my next equation, 1 plus the square root of 2x minus 2 equal to x. We need to start by getting everything on one side of the equation, or everything that's not the square root on one side. The square root should be alone on one side of the equation. So 2x minus 2 equal to x minus 1. Squaring both sides, the square and the square root cancel each other's out. That gives me 2x minus 2. The right-hand side, I'm going to do a little bit of scratch work over here. Squaring means I need to FOIL this out. That would be x squared minus x plus 1. In other words, x squared minus 2x plus 1. Since we have an x squared, we want to get everything on one side. So I'm going to subtract 2x over and add 2. That gives me x squared minus 4x plus 3. And this can factor into x minus 3, x minus 1. That tells me x minus 3 is equal to 0 or x minus 1 is equal to 0. So x is 3 or x is 1. And we do need to double check both of these. So if I check x equal to 3, that would be 1 plus the square root of 2 times x, which is 3, minus 2, should be equal to x, or 3. This is 6 minus 2 equal to 3. So I have 1 plus the square root of 4 is equal to 3. In other words, 1 plus 2 is equal to 3, so this is valid. What about x equal to 1? Now I have 1 plus the square root of 2 times 1 minus 2. Should be equal to 1. Well, that's 1 plus the square root of 0 equal to 1, which means 1 is equal to 1, which works. So both of these are valid solutions to this equation. My next one, the square root of 10 minus x equal to x plus 2. Once again, we start by squaring both sides since my square root is already alone on the left-hand side. The square and the square root cancels each other out. I have 10 minus x. The right-hand side, I do need to FOIL this. So that's x squared plus 2x plus 2x plus 4. Or in other words, x squared plus 4x plus 4. Since we have an x squared, I want to get everything on one side of the equation. Subtracting 10 and adding x to both sides gives me x squared plus 5x minus 6. And we can factor this into x plus 6, x minus 1. So we have x plus 6 is equal to 0 and x minus 1 is equal to 0. Or x is minus 6 and x is 1. Let's check these answers. Let's start with x equal to minus 6. That's the square root of 10 minus negative 6 equal to negative 6 plus 2. This says the square root of 16 is equal to -4, or 4 is equal to -4, which is wrong, so this is not a solution. Let's check 1. So the square root of 10 minus 1 equal to 1 plus 2. Or square root of 9 is equal to 3. Or 3 is equal to 3, which is valid. So my only solution here is x equal to 1. Let's do one more. The square root of 3x squared plus 10x equal to 5. We know we need to start by getting the square root alone on one side, but we already have that. So we can go ahead and square both sides of this equation. The square and the square root cancel. I'm left with 3x squared plus 10x. The right-hand side, 5 squared, is 25. We can subtract 25 over to get 3x squared plus 10x minus 25 equal to 0. And then we want to try to factor this. The only thing that multiplies to be 3 is 3 and 1. For 25, well, we know it's 5 and 5, so let's try that. As we FOIL this, 3x times x is going to be, so I'm going to do this right underneath, 3x squared. 3x times 5 is 15x. 5 times x is 5x, and 5 times 5 is 25. We know this needs to be a minus 25, so one of these terms here should be positive and one should be negative. And this is going to work if I do plus 15 and minus 5. So I need to do a minus here and a plus here. That gives me 3x minus 5 equal to 0 and x plus 5 equal to 0. If you solve these equations, you get x equal to 5/3 and x equal to minus 5. So let's check. Let's start with checking -5. This is 3 times -5 squared plus 10 times -5. Well, 5 squared is 25, times 3 is 75, minus 10 times 5 is 50. So that's the square root of 25 equal to 5, which we know is correct. So -5 is a solution. What about 5/3? Well, that would be the square root of 3 times 5/3 squared plus 10 times 5/3. If we try to simplify this, 5/3 squared is 25 over 3, or 25 over 9, which times 3 would give me 25 over 3. Here we have 50 over 3, and that should be equal to 5. 25 over 3 plus 50 over 3 is 75 over 3. And 75 over 3 is just 25. And we know the square root of 25 is 5. So in this case, both of these are valid solutions.